Hi, in this tutorial we're going to see how to rig the tail of a creature with an IK-FK switch. This is my creature here, which I rig with a normal human IK. And of course, I was only able to rig the torso, the neck, and the legs, but not the tail. So if I display my bones, I can see here I have a tail chain, just a simple FK chain with just a few bones. And what we want to do is rig it. So first I'm going to create FK controls that look similar to this. I'll go to Asset Browser, Elements, and creating skeleton node. So drag and drop this here. I'm going to drag this node on my tail, align, and I probably want that to be bigger. Skeleton node settings, can increase that size a little. I will rename that to control tail 01, and I will parent it to the hips of my character, the FK controls. So basically duplicating the tail skeletal hierarchy as FK controls in yellow, just like our FK controls are perfect transcription of our bones for the rest of the body. So I have a few other tail bones, so Control C, Control V, which creates a duplicate, okay, tail 2, and I will reparent that here and align it to the next bone, and so on. Control C, Control V, align to the next one, parent, Control C, Control V, and align and parent. So don't parent the controls to the skeleton. We want to keep the controls and the bones separate. Just let me redo some renaming here. And I'll add an extra bone at the tip. We'll need that for our IK solving. Now I will add these controls to the character's extension. In my navigator here, I have character extensions. I'll create a new one for my character. So I'll select my character here, create character extension. And call it tail. I'll select this character extension, go to properties, and I will make sure the reference object is the pelvis bone of the character. And make sure the attached character is the one you're working on. Now I just have to add all my tail controls to this extension. So for now, these don't do anything. So the next step is to constrain the bones to the controls. And for that, since I built this original rig with my template scene, I have a few constraints here that already exist where I can constrain bones to controls and controls to bone. So in my bone to control relation, I want the bone to be constrained to the control. So I will select all the tail bones and set them as receivers. And in my second constraint, I will add them as senders. Same with the tail controls, but vice versa. So receivers in this constraint, and in the other constraint, bone to control, the bones are constrained to the controls, so the controls are the senders. And I will link rotation and translation. Of course, if you want like squash and stretch or scaling, you can link the scale. Here I want to do like a realistic rig where bones can't deform, so I won't add those. And we have the extract control here for the tail tip, but this one doesn't directly control any bone, so actually I can remove that. Same in the other one. Up in here, rotation, translation. Okay, and so those two constraints, they are driven by the master relation import mode. So when I import, I enable this. The controls are constrained to the bones, so the incoming motion file drives everything, and I can bake to the control rig. And then I deactivate that when I want to animate, so the controls drive the bones, which is the case here. I have my yellow controls driving the tail. And if I enable this, the controls don't do anything, but bones do. So when you animate, you disable import mode. So we have a very simple FK chain here that's part of our character. So you can check that if you select one of the tail controls, you want to make sure that if you store a pose, you have this icon which shows that the pose is part of the character. Okay, so also you can key in body part, and you can see it's yellow, so it shows you that you have a key on the character extension. And actually if you key on the entire full body character, that should also work. Even if I select another body part and I delete that key, that affects the tail because I'm in full body. So everything works. We confirm that the tail is part of the character thanks to our character extension tail. And the proof is that the FK controls are now semi-transparent. Now that we've created our FK controls and they're nicely positioned, we want to make sure we select all of them and key them on the A pose. So we really save this position and make sure we don't break it later on. The next step is to create our IK controls. So I can just duplicate that hierarchy and parent all those bones to the reference directly. So instead of being an FK chain, meaning that you have parent and children, all these will be directly parented to the reference. So basically they will be in world space. Let me rename a little bit. And I will change the look of these so we don't mistaken them for the FK controls, and so everything is easy to select. So in properties, I'll change those to circle, for example. Okay, I'll make them red. It's just to follow, the visual convention that we already have from the human IK rig, where the IK controls are in red. Because I selected a circle, sometimes they're not oriented like you would want them, so you can go to transform pivots, geometry offset, and this lets you offset the model but not the pivot of the actual object in the scene. In this case, I want to offset on the z-axis. Okay, so on z I'll do a 90-degree offset. Okay, and I'll scale them up a little, so I can use the scaling or I can use the size here. And I'll use the size, it's easier, I can just use one value. Okay, I'll make that one way bigger. I want to make sure they are easy to select even without the see-through model, the X-ray. And of course, I don't want to forget adding the IK controls to the extension as well. I can put them in the same character extension tail. And now that our IK controls are nicely positioned, we want to make sure we select them all and key them to capture this A pose and make sure nothing breaks. So we have our IK controls, and now we need to create a relationship between these IK controls and the FK controls, because for now the IK don't do anything and the FK is the only one driving the tail. And I want to explain you a little bit what constraint we're going to use for that. We're going to use a 3-point constraint, not an IK constraint. And the reason for that is that the 3-point constraint lets you handle rotation as well. So I have a simple setup here where I have my green marker in the center, and it's going to be driven by those 3 nulls. I'm going to create a 3-point constraint so you easily see how it works. But eventually in our creature rig, in our tail rig, we'll use a relation constraint, so it's just easier. So my constraint object is the marker, my origin is this one, my target is that one, and I have the up object here. I will snap and lock, and now if I take one of these objects and move them around, you can see my marker tries to aim at it. Okay, I can move the base, I can move the up object, so it's influenced by the 3 objects basically. So there's one pointing, there's a base, and there's an up vector. So it's similar to look at basically. So in our creature rig, let's create a first relation constraint, relation tail IK. We're going to take our entire FK chain and put them as receivers, because this is a constraint where the IK is driving, okay? And later on we'll make a switch. I'll select all my IK controls and use them as senders. And we'll need a few more objects because I also need the an object up. To explain you a bit better, if I go back to my simple constraint example here, imagine that the marker here is just one of the tail control, FK control, and this object here, the base, will be the IK control that has the same position as the FK control, and the tip will simply be the IK control of the next FK control. So imagine these are like different bones in a tail, like vertebrae. This will, like, every time it will aim to the next FK bone, basically like this. And that's why we had to add an extra one at the tip, because if this is the last bone in the chain, you need an extra object to drive the tip and orient that bone, basically. So it's like an imaginary bone, it's just a control. So what's missing here, it's basically this object. Like in this scenario, we don't have an object to drive the up. So we're simply gonna imagine another object here, okay, that we'll use as the up. So this object here will be the up for my first bone, and the object here will be the up for my second bone. And this guy will be parented to the IK here, and this one to the IK there. So these up objects are the only thing I'm missing. So I'm going to add a few nulls that I'm going to parent to each IK control. So tail up 0, 1, for instance. So every time I duplicate, I reparent, I align, and I rename to have exactly the convention that I want. Okay, so all these objects right now are at the same level as the IK controls, you can see here. And what we want is to have them up like this. So I'm just going to grab them all and set a value. So here it's on the y-axis, okay, like so. I can just select an arbitrary value, like yeah, 60 for example. And later on, I'm not going to need those because the animators are never going to interact with those directly. So I will eventually hide them, but for rigging purposes, I'll keep them visible for now, and I'll actually make them a little bigger. Actually, I won't need the last one because this one won't drive the rotation of anybody because there isn't a bone after that. So I can delete that one. Now let's go back to the relation constraint, and I can add these up objects as senders. And now in rotation, I can select the node 3-point constraint. So that's why we use the 3-point constraint. There isn't an aim at node here. So that's the only one we can use. This way we can have one relation constraint that handles the 3-point constraint for each bone in the tail, which is much easier to manage if you have a very long tail with many bones. You wouldn't want to have, like, I don't know, 10 aim at constraints here in the drop down. It's easier to just have it in one relation. So now I just need to do some linking, right? So on the first FK control, I want this IK control to be the object A. Object B will be the target. So it's the next IK bone. And C will be the up object. So it does cross the links, which isn't nice visually, but it still works. And now if I connect the rotation to my first FK control, normally you shouldn't see any pop because you've based everything on correct alignment. Now if I take this up control and I move it manually, you can see that it twists the tail. If I move this one up, it does some kind of behavior like this. That's okay. And if I move that one like this, you can see that the tail is pointing at it. So this is working. We didn't mess up our linking here. So based on that model, I'll just duplicate the 3-point constraint node and create the constraints for the other FK controls. Actually, I'll disconnect everything, copy it multiple times. 1, 2, 3, 4. Okay, so this guy here will drive this one will drive this one will drive that, and that. The next one will drive the previous. Oh, I actually have, one that's not needed here. And the up object will be C every time. Up. Now I can safely plug my rotations, but I'll make sure to look at the viewport, make sure nothing explodes. Alright, so we basically have this setup where you can drive the position of each bone with the IK controls. Technically, you could do a stretchy rig where if you move the IK control too far, the FK control would follow. For this, you can simply control the translation of the control. So if I move this one here, basically I want the translation of my tail 2 to be driven by the translation of the IK tail 2. Okay? In this case, I can make the translation longer. That's an option. Otherwise, you can also just let the animators control this, the translation of the FK controls directly. Personally, I prefer to make here a simple and realistic rig where things can't stretch, and it's just based on aiming. So an FK bone looks at the next IK control, but an FK control doesn't directly follow the IK controls translation. The next thing we want to do is another constraint where the IK controls follow the FK controls to have a simple IK-FK switch. So I'm going to disable the tail IK constraint. I'm going to create a new one, relation, and call it relation tail FK. This time the FK controls are going to be senders, and the IK controls are going to be receivers. I simply need to link the rotation one-on-one and translation. So now if I animate my tail in FK, the IK controls follow, and they will be baked onto it. And I don't need to input the up objects because the up objects are directly children of the IK controls, so they already inherit the tail's twist, right? If I do this, you can see the up objects also twist around. Actually, we won't need the up objects anymore, so I can select them all, set the viewer options, disable transformation and selection, and change their look to none. Now we need to make sure to also add the IK controls in the control to bone constraint, so that when we import an animation, the skeletal data that comes from the motion file will directly be baked on the IK controls as well. This way the animation will properly be baked whether the IK or the FK relation constraints are active. Let's just link the same values, translation, rotation. And I'll just add this little guy here, the tip of my tail, as a sender to drive the last tailbone. Make sure it's in the correct order. So 4 onto 4 and 5 onto 5. So now you may wonder how to use the rig. So if you have to give it to an animator, this is how to use it. So I'm quickly gonna block out an FK animation here. So selecting all my FK bones. And quickly doing something like this. And at some point my tail will actually go through the floor a little bit. So I have this very rough animation here. And now let's say I want to go to IK. I'm going to select any control of the tail. In full body or body part, I will plot. And now I can switch my constraint around, so deactivate the FK and activate the IK. Nothing seems to change because I baked, so the IK and the FK controls are on the same spot, but now it's actually the IK controls driving everything. So I can edit the animation with the IK controls. So for example, I can delay some of those. For example, taking the last 3 bones and delaying them a bit. To create some delay. Now you can basically make the rig more complex as you want. For example, you could have one control at the tip that kind of drives the rest of the tail if you want to quickly block out the tail. So let's try and do that. I'm gonna duplicate my last IK control here, call it maybe control tail master, for example, parent it to the reference. Okay, it's flipped for some reason, so transform pivots, geometry offset. I want to rotate it on Z, like so. I'm going to make that maybe a square. Increase its size. Maybe make that orange, why not? So I'll add this guy to my character extension, as always. Tail. And my goal here is to make something that, if I move it like that, I'd like the tail to, you know, kind of try and bend like this and try to follow that. So what I want is, you know, objects that will be a little bit driven by this control and a little bit driven by the one at the base. And those should basically drive my IKs. And I should be able to animate the IKs with an offset from it. So if I want, I could, you know, move that one up and shape the tail like this if I want, right? And so the blue controls, there will be, you know, this first one will be influenced maybe at 75% by the master. That one might be influenced at 50%. That one maybe 25, you know. So I need to create some parent constraint and some objects for that. So I'll simply duplicate my IKs once again. Not the first one actually. I'll put them in orange, I remember as well. Tail mastered. That one will be 02. That one will be 03. Okay, so 02, 03, and 04. Okay. Actually, I will make these children of the first one. And I'll key them, now that I've changed their parenting. And I'm going to create a bunch of parent constraints. So parent, tail, master, 02. Okay. Every time I'll have the base as the first parent, the master control as the second parent. Okay, I'll duplicate that. Maybe put that in a folder. I'll actually put that folder in my don't touch folder, so animators don't have to worry about it. And I'll put the constraint object, so this guy here. That guy over there. And that guy over there. And I'll kind of, before I hit snap and lock and everything, I'll prepare the values. So I'll say that, so if I do it now, right, if I do snap and lock, if I move this guy here, okay, this control here is kind of influenced 50-50 between the two objects, right? So what I can do is say, maybe the master here only has 25 influence. So now if I rotate that first guy doesn't rotate as much. Okay, up, so I'll snap and lock the other constraints. And for this one, let me actually animate the control. So on the first frame it's static, and on the next frame I'll move it like so, and now I can tune a little bit my my profile, okay, my tail profile. So basically this one here can have 50, and this one here might have 75. Okay, and actually here it will be 25, here it will be 50, and here it will be 75. So the sum equals 100, right? Between the first IK control and the master, the tip of the tail, it's like the sum equals 100. So see, it's reversed: 75, 25, 50, 50, and 25, 75. So it gives us an idea of the profile. Okay, so I'll basically have this control to quickly like offset my entire tail. Okay, and now all I need to do is well, actually I shouldn't have parented those guys directly under the tail here. So I will unparent those. But I can parent my IK controls under them. So up, 02 under master, 03 under meister, and 04 under master over there. Now when I do this, up, it influences the IK controls, meaning that if I'm in IK mode, here, my tail follows this. And again, I can animate these guys on top. Okay, so I don't need to see the orange ones anymore. I'll just use the viewer option to hide them and disable transformation selection. To finalize the rig, you need to make sure to add the master control in the FK relation as a receiver, so that when you're in FK mode, the last bone drives not only the last FK control, not only drives the last IK control, but also the master control. Similarly, in the driven constraint, control to bones, so controls following the bones, you also need to add the master as a receiver, where it will follow this guy, the last FK control. So in IK mode, it drives everything, but if I jump to FK mode, it follows the tip of the tail, just like the IKs. And if I'm in import mode and the bones are driving everything, everything follows, the control follows. And that's it. Thanks for watching.